Hi class, this is Neil, and this is the second video for lesson 2 of unit 9, where we're looking at angles in the coordinate plane. So this video is going to correspond to the first part of the lesson, which has to do for variables for an angle, what we call quadrantal angles, standard position and terminal side. These two examples, example 1 and example 2, and then we'll look at 2 of the practice problems together. So that's what we'll be doing in this video. I'm going to be transitioning over to the slideshow to do most of that work, but you should be taking notes either on a printout of this or in your notebook. All right, so the goal of this lesson, really, and as you're kind of watching these angles rotate around, is we want to extend the idea of angles and extend the idea of trig functions beyond just a right triangle. So far we've only been thinking about trig functions when it comes to a right triangle. Today we're going to really look at how can we think of extending both trig functions and our understanding of angles beyond just 90 degrees. So there's a place on your notes to record this, but this is something that's very important when it comes to studying trig functions. We often use a special variable for angles, and it looks like a 0 or an O with a line drawn through the middle. That's really the Greek letter theta. So oftentimes when you see the variable, which looks like a 0 with a line through it, we say theta, and that normally represents an angle measurement. So you can pause the video and take a note on that variable if you need to. Okay, so quadrantal angles are it's a really kind of crazy word. Sounds really complicated, but what that really means is the angles that create the 4 quadrants. And it's important how we label them. So if I just trace a line along the x-axis in the positive direction, that's where we're going to start all our angle measurements from. And so that angle formed with the positive x-axis is 0 degrees. Now, if I extend that angle all the way to the y-axis, that forms a 90-degree angle. If I extend that angle further, another 90 degrees, that gives me a 180-degree angle, and you'll notice I'm in the negative side of the x-axis. If I extend that angle another 90 degrees, I'm in the negative side of the y-axis, and the angle formed if I go 3 turns around the coordinate plane is 270 degrees. And now finally, if I start again from my starting place and I rotated all the way around the coordinate plane, I would have traveled 360 degrees. So you should take note that when we're talking about angles in the coordinate plane, 0 degrees, where 0 degrees happens, is the same place that 360 degrees happens. And again, this is as we move from quadrant 1 all the way to quadrant 4. Okay, so just so you know, that corresponds in your notes with this section called quadrantal angles. So you might need to rewind the video just a little bit to take notes on that section. All right, the next thing we're going to talk about when it comes to angles in the coordinate plane is standard position and terminal side. Okay, so standard position is an angle whose initial side begins at 0 degrees or the positive x-axis. So what that really means is this is always where we start measuring the angle from when we're talking about standard position. We start in the positive x-axis. The terminal side is the ending side of the angle. So it's wherever that angle ends up. In this example, the ending side or the terminal side occurs here. So we measure the angle from where we start to where we end. All right. So again, if I were to label this example, my initial side or my starting side is on the positive x-axis. The terminal side is where we end up. So you could pause the video, take notes if you need to. Okay, so for these two examples, what we're going to look at is sketching angles in the coordinate plane. So for example 1, we need to sketch the angle theta. Remember the 0 with a little line through it means theta, equal to 110 degrees in standard position. Okay, so to start this out, what I would always suggest you do is go ahead and label those quadrantal angles as a guide. So starting on the positive x-axis, we have 0 and we also have 360. If we go all the way around, 90 appears at the top, 180 is the negative x-axis, 270 is the negative y-axis. All right, so to sketch that angle then, we would ask ourselves, where would 110 degrees appear on the coordinate plane? And you're right if you said that it's going to happen somewhere between 90 degrees and 180 degrees. You're absolutely right about that. So to sketch that, I'm going to just take my best guess. 110 is really closer to 90 than it is to 180. So I'll extend a line where I think 110 degrees is. And then I'm going to indicate that that's my angle by drawing an arrow from the x-axis to the terminal side of that angle. And that's this little arrow that you see here. And I'll label that with 110 degrees. Okay, for my second question, example 2, I'm asked to sketch a 300-degree angle in standard position. So again, I'm going to start that problem just by labeling all my angles. So I've got 0, 90, 180, and 270. Those kind of act as my guide. And what I want to ask myself is, where would 300 degrees appear in the coordinate plane? Well, you're right if you say it's going to appear somewhere between 270 and 360. And now we're going to kind of estimate that that angle is going to be somewhere kind of closer to 270 than 360. So I'll draw a line where I think that's going to be, which I did here. I'm going to, in red or in a different color, if you only have a pencil, that's fine too, draw an arrow that's going to rotate from the initial side of the angle all the way around to where 270 degrees is, like I did here. All right, so that's how I indicate that that's that angle measurement. And then I'm going to label that, I'm going to label that with 300 degrees. All right, you can pause the video here if you need to take notes. All right, so sometimes, like I mentioned before, we always want to, when we're sketching these angles, draw for ourselves our reference angles, or our angles that are going to be not reference angles really, but guide angles. So we've got 0, 90, 180, 270, and coming all the way back around, we're at 360. If you wanted to make a better approximation, we could sketch in other guide angles for us. So I could sketch in a 45-degree angle, and that gives me a better sense of where other angles are located. So if I drew in a 45-degree angle between 0 and 90, I now know where a guide angle is for 45 degrees. Between 90 and 180, if I went 45 more degrees, I'm at 135. So that's another guide angle for us. 225 degrees is another guide angle. That's at 45 degrees away from 180. And now finally, the last guide angle that I could draw there could be 315, because that's 45 degrees away from 270. So if I was asked then to sketch, let's say, a 140-degree angle, where is that located at? Well, what I could do, if I have all my reference angles in, starting with the terminal side, or the initial side of that angle, pardon me, starting with the initial side, that's where I'm going to start. I'm going to 140. Now remember, I know where 135 is, so 140 is going to be pretty close to that. And now I'm going to sketch in my arrow to show you that that's the distance I've traveled. And I would label that 140 degrees. All right, so let's go ahead and look at two examples. All right, so we need to sketch here each of the angles below in standard position. And then we also need to answer which quadrant is the terminal side of the angle in, or where does that angle end up? So terminal side is where do we end up? Okay, so remember, we're going to start these problems by drawing in our guide angles. So I know that's 0, 90, 180, 270, and then if we go all the way back to 0, we're at 360. All right, so I'm going to switch colors here. Now, 45 is pretty easy. It's between 0 and 90, and in fact, it's halfway between 0 and 90. So I'm going to sketch the initial side of that angle. 45 degrees, like we said, is halfway in between 0 and 90. So I'm going to sketch a line that is halfway in between there. And now I'm going to indicate the distance that I traveled here by drawing an arrow from the initial side to the terminal side. And I'll label that 45 degrees. Okay, if you were doing this on your own notebook paper, the only additional thing that you would have to sketch are the x and the y axes. So before you would start this problem, you would want to draw your x-axis and your y-axis, and then indicate the angle once you have the axes drawn. All right, so for question 2, before we move on to question 2, left off part B. So in part B, which quadrant is the terminal side of the angle in? Well, the terminal side is right here. This is the terminal side, and we're still in quadrant 1. Okay, for question 2, we're asked to sketch an angle that's 172 degrees. So again, I'm going to start this problem by labeling really my quadrantal angles or my guide angles for myself. So 0, 90, 180, 270, and then we're back at 360. Let's maybe zoom in on that problem. All right, and I'm going to always start my initial side in the same place. So my initial side here is the positive side of the x-axis. And now I'm going to 172. Well, 172 is between 90 and 180. And it's a lot closer to 180 than it is to 90. So I'm going to approximate where that would be. Right, that's about where 172 would be. And now I'll draw an arrow indicating the distance that I've traveled from the initial side to the terminal side. And finally, I'm going to label that 270. Sorry, not 270. I'm going to label that 172. For part B, we really want to look at what quadrant are we in. So if I label my quadrants 1, 2, 3, and 4, that angle ends up in quadrant 2. All right, so that's question 1 and 2. What I'd like you guys to work on is question 3, 4, 5, 6, and 7. So that's what you'll be working on your own. We could take just one look at question 5. Now, when I draw on my quadrantal angles, that gives me a sense of where different angle measurements are. Here we're supposed to do an angle measure or theta measure of 57 degrees. So for this problem, you don't have to, but you might want to draw your other guide angles. So here's 45, 135, 225, and finally 335. Nope, 315. Okay, so to do a 57-degree angle, again, we always start in the positive x. That's our initial side. Now that 45 degrees gives me a better sense of maybe where 57 is in relation to 90. So about here. And then, of course, I would sketch in how I'm traveling. So from the initial side to the terminal side, and I would label my angle. Well, I didn't mean to do that whole problem for you, but I guess I did. But still, you should turn in questions 3 through 7. And if you want to try question 8 and question 9, those are really challenges.